Quadratic expressions and equations, special products. There are certain products of binomials that occur quite often to the point where it would probably be a good idea to learn to at least recognize when you have these products. So, for example, here we have a few of the more common special products that occur. The first one is difference of two squares. When you have, let's say, a squared minus b squared, that's always going to be a plus b and a minus b. The sum of squares, a squared plus b squared is equal to a prime number. Then you have either your perfect square trinomial, which is when you have like an a plus b and that's all squared. And similarly, you have your a minus b and that's all squared. You have your sum of cubes. In your sum of cubes, you're going to have an a plus a b multiplied by a squared minus ab plus b squared. And that's all going to equal a plus b cubed. Then you have your difference of cubes and binomial of cubes. So these are just a few of the ones that you should learn to recognize them. And I'll do a couple examples here. This first example, 4 times y to the 2n minus 8. That's it's pretty obvious what you can do here. You can factor out a 4. So when you take this and you divide both of these values by 4, divided by 4 and divided by 4, you're going to be left with, you're going to factor out a 4. You're going to be left with y to the 2n minus 2, because 8 divided by 4 is 2. That's your final answer. Here we have to find our common factor. Now, in terms of the whole numbers, both of these 5 and 20 are factorable by 5. So that means we're going to end up taking out a 5. And in terms of our x values, x to the 4n and x to the 3n, that means x to the 3n is a factor of both of these. So we're going to essentially take out an x to the 3n. Now, when we take this out of our original polynomial, what we're gonna end up with is, let's say we divide 5x to the 4n divided by 5x to the 3n. All we're gonna be left with is x to the n power. Then we're gonna subtract 20x to the 3n. So 20x to the 3n divided by 5x to the 3n. Well, our x to the 3n's are gonna divide out. Now 20 divided by 5 is just 4. So what we're left with is this. And that's our final answer. Same thing here. Let's first look for the whole number that is factorable by each one of these terms. 8, 4, and 2. The largest common factor that we can get out is a 2. So let's put a 2 out front. In terms of our p's, we have a p to the 5n, a p to the 4n, and a p to the 4n. That means we can factor out a p to the 4n. That's our largest, or that's our smallest p exponent. So we're going to factor out a p to the 4n. In terms of our q's, q to the 2n, we have a q to the 3n, and we have a q to the 4n. That means we can factor out a q to the 2n. So now when we factor out 2p to the 4n, q to the 2n from our first term, well, when we factor out a 2, we're left with 4 instead of 8. When we factor out a p to the 4n, we're left with just a p to the n. And when we factor out a q to the 2n, we're not left with anything else inside. We're just left with a 1. So that's our first term. Let's subtract our second term, 4. When we factor out a 2 from 4, that just leaves a 2. When we factor out a p to the 4n from 4p to the 4n, that just leaves a 1. So this one's going to essentially factor out. A q to the 2n and a q to the 3n, that means we're going to be left with a q to the n. Our last term, when we factor out a 2 from 2, that's going to leave a 1. When we factor out p to the 4n from p to the 4n, we're going to be left with a 1 still. And when we factor out q to the 4n from q to the 2n, we're going to be left with q to the 2n. So then this becomes our final answer. Here we can actually factor out, this one's quite simple actually. We can factor out an a minus b because both of these terms have an a minus b. So we're going to take out our a minus b, and we're going to be left with parentheses x plus 7 plus x minus y squared. Now we can add these terms together. A minus b stays the same. We have two x's, so it just becomes 2x. We only have one whole number of plus 7. And then we have one negative y squared. We have one y term, so it just becomes minus y squared. And this becomes our final answer. Here we want to factor out our greatest common factor out of the first and the second group. So here we have an ax squared minus a minus x squared plus 1. So what I want to do here is I'm going to factor out an a from the first term. So a, we're going to be left with x squared minus 1 inside the parentheses. And we're going to factor out on the second term. We're going to factor out a negative 1. And that's going to leave us with an x squared plus, or actually minus 1 in our second group. Actually, now we can factor out x squared minus 1 from the whole thing. So when we factor out x squared minus 1 from all of this, we're going to be left with an a minus 1. This last term, we can actually factor it out even further. And this is actually a factor difference of squares, if you remember. Our difference of two squares, a plus b and a minus b, is going to equal a squared minus b squared. Well, here, our a is going to be an x, and our b is going to be a 1. So what this means is that we're going to have x plus 1 and x minus 1, and then our last term, a minus 1. And this is our final answer.